Hello students, today we are going to see some more interesting and important questions from Narendra, Avasthi sir's physical chemistry, mole concept. Come on, let us discuss few more questions from this session. The first question, what percentage of oxygen is present in the compound CaCO3 and Ca3PO4 twice? That is calcium carbonate and calcium phosphate. You know what are the steps to follow to find out the sum? Right, the first one we have to find out the molar mass of each, that is molecular mass of each. Right, the second one, how many oxygen atoms are present in both. So total oxygen atoms, and the third one you have to find out the mass of total oxygen atom. Then finally you have to go and identify the percentage of oxygen atom. That's all, simple. Okay, come on, let us find out all these points. Right, the first one, calcium carbonate and the calcium phosphate. No, so calcium carbonate CaCO3 and 3 units of Ca3PO4 twice. So let us find out the molecular mass of each. So molecular mass of each means this is 100 gram per mole, you know very well. And the same way here, calcium, you know very well. Calcium, it is 40, phosphorus, it is 31, oxygen, it is 16, and 4 oxygen atoms are available. And here 3 calcium atoms. So altogether you will get around 310 gram per mole. But here 3 units are there, no? So 3 into 310. So you will get totally 930 gram per mole. So the molecular mass of calcium phosphate, 3 units of what it is, calcium phosphate, that is 930, and calcium carbonate 100. So total mass of these compounds, total mass of these two compounds. So how much it is actually? Here 100, this is 100, one second. Yeah, this is 100 plus this is 930, altogether here 1030 gram per mole. Now the second step, we have to identify how many oxygen atom in each. So in that calcium carbonate, number of oxygen atoms in CaCO3 and next one Ca3, 3 unit Ca3PO4 twice. So this is how many oxygen atoms that you know very well, 3 oxygen atoms. Whereas here 4 oxygen atoms, that is actually 4 2s are 8, right? So 4 2s are 8 oxygen atom. Actually 8, it is 3 units is there, no? So we can go for that 8 into 3. So you will get 8 into 3 units complete. So you will get what it is, 8 3s are 24 atoms, right? Got it? This is 3 atoms. So now total number of atoms, total number of oxygen atom, total number of oxygen atoms, how much it is? 24 plus 3, altogether 27 atoms, right? Got it? So total number of oxygen atoms present in these two compounds, it is 27 atoms. Okay, now mass, we have to find out this oxygen atom. So mass, how much it is? Mass of oxygen, it is 16 gram per mole, no? So 16 into 27 atoms. Mass of oxygen atom, oxygen atoms, that is actually 27 into 16 gram per mole, right? How much here you are getting? You'll be getting 432 gram per mole. Got it? Now you have to identify the percentage of oxygen. I hope you got that idea. Now percentage of oxygen present in these two compounds. Present in these two compounds. I just mentioned here. Present in these two compounds. What are those two compounds? Calcium carbonate and calcium phosphate. That is 3 units of calcium phosphate. These two compounds. Compounds already I just mentioned, just check it. Right now here what it is, here what is the formula, you can bring it over here, no? Total mass of oxygen, total mass of oxygen, right, divided by total mass of the molecular mass, total molecular mass. So total molecular mass, just now we found both together it is 1030, and the total mass of oxygen atom only it is how much? 432, right? So come on, can you apply those two values over here? So percentage of oxygen atoms, so here 432, that's what mono atom, right? That's what oxygen atoms. Right now here 432 divided by 1030, right? 1030 only, right? Into 100. Percentage, no, 100. So this is how much you'll be getting. You'll be getting percentage of oxygen atoms, right? So you'll be getting how much here? 41.94 percentage of oxygen, right? I hope you got that clarity. What are the steps to follow? How easily we can understand? Come on, what is the answer? Come on, let us go and identify. Here the answer it is 41.94. Yes, it is appearing over here. So 41.94. So option C is the correct option, right? Come on, let us go to the next question. The next question, Dieldrin, an insecticide, contains carbon, hydrogen, chlorine, and oxygen. Combustion of 29.72 milligram of dieldrin gave 41.21 milligram of carbon dioxide and 5.63 milligram of water. In a separate analysis, 25.31 milligram of dieldrin converted, that means dieldrin was converted into 57.13 milligram of silver chloride. What is the empirical formula of dieldrin? Okay, so in that first analysis, combustion of dieldrin, it is actually 29.72 milligram of dieldrin gave 21 milligram of carbon dioxide, and water, how much? It is 5.63. Okay, in the first analysis, that is during combustion time, dieldrin sample how much? 29.72 milligram. In that water, due to the combustion, carbon dioxide and water, it's coming out. So carbon dioxide, how much it is releases, that given mass, that is 41.21 milligram. And water, how much? Water, it is 5.63 milligram. Right now, in the separate analysis, here what it is, 25.31 milligram of dieldrin was converted to 57.13 milligram of silver chloride. Okay, now another analysis, what they have mentioned, chlorine they have mentioned. So chlorine, how much they have given here? Actually, in a separate analysis, dieldrin, that is another one more thing, it is around another analysis, it is 25.31 milligram of dieldrin, which is converted into what it is, 57.13 milligram of what it is, AgCl. So AgCl, due to that, another one more. This is also dieldrin only. Dieldrin, you know what it is, dieldrin? It is an insecticide. Come on. Now, let us find out each thing. So now we have to identify that given mass of carbon and given mass of hydrogen and given mass of chlorine. Let us identify. So here, given mass of mass of carbon. So how do we identify each thing? Carbon, hydrogen, chlorine, then oxygen, then finally we can identify the empirical formula, right? Okay, now how to identify? So this is easy to identify actually. What it is, atomic mass of carbon, what it is, 12. And the molecular mass of carbon dioxide, what it is, 44. It is gram per mole, both gram per mole, and this is also gram per mole, into given mass of what it is, due to the combustion, at this much it is releases. Now how much it is? 21 milligram of carbon dioxide. So we can find out that what it is, given mass of carbon. So here this and this will be cancelled. So gram per mole, gram per mole. So when you calculate it, you will get what it is, 11.25 milligram of carbon you will be getting, right? Okay, and the same way hydrogen. So hydrogen, given mass of hydrogen. So the same way, atomic mass of hydrogen divided by molecular mass of water. From water only hydrogen we can identify. So here water 18 gram per mole, and this is a gram per mole, right? Why I'm mentioning now, this is milligram also it is mentioning. Given mass we have to identify. So this is 5.63 milligram. So milligram here, gram per mole will be cancelled. So you will be getting around how much? 0.63 milligram. So given mass of hydrogen we found out. Now chlorine we have to identify. Chlorine also another separate analysis. Chlorine. So chlorine, how much it is? A sample of chlorine. The sample of the dieldrin in that chlorine. Okay. So sample of dieldrin. It is what it is, 25 now, it is 25.31 milligram, right? In that AgCl, how much? AgCl has converted 57.13 milligram. So in that chlorine, given mass of chlorine, so how to deal that? The same atomic mass of chlorine. What it is? 35.5 divided by mass of molecular mass of AgCl. It is 143. 143 into given mass of AgCl 57.13. So you will be getting around how much? You'll be getting chlorine mass now. You'll be getting around 14.13 milligram, right? So you are getting all that. What are those three things you'll be getting? Given mass of chlorine, right? I just put it in there. So given mass of chlorine, given mass of oxygen, and given mass of hydrogen, and given mass of carbon, right? Given mass of carbon. Okay, now these three things. Now empirical formula we required to know. That is what I just put it in the box. Yes, come on, data are very important. Now we have to find out that sample, the first sample what we have due to the combustion time, dieldrin, how much it is having actually. First time before that getting for conversion of AgCl, that is before one, it is 29.72. Here the first time carbon, hydrogen, chlorine and oxygen is there. Now in that also chlorine is available, not only AgCl, right? So that means the first time chlorine, it is actually what it is, 29.72 29.72, that whole scaled chlorine, and the second time chlorine it is 25 point. Okay, now we have to identify complete chlorine mass. So this is only for AgCl how much chlorine is there. Right now here in that point, so here scaled chlorine we can sample chlorine we can sample of drin sample in first, right? So here what it is, 29.72 milligram, and then second one that is AgCl, it has converted now, so that is actually 25.31 now. Yeah, so 25.31 milligram, and this is chlorine mass, how much it is, 14.13 milligram. Now let us calculate that to find that what it is, given mass of chlorine on the whole. So given mass of chlorine, because chlorine it is there for both, it is not only for only for AgCl what they have converted, even drin chlorine it is mandatory. So this is what we have found, that this is from AgCl how much it is milligram, and then drin one more sample also it's available. No, so that means how do we identify? That is first sample 29.72 milligram divided by 25.31 milligram into 14.13 milligram. Right, everything milligram only. So you will be getting around how much? 16.5 milligram, right? 16.5 milligram of chlorine in that drin. Right, now we found what it is. We found the carbon, hydrogen and chlorine. Now we have to identify oxygen. So finally we can go for what it is, empirical formula. Okay, now oxygen, mass of oxygen. So here mass of oxygen, how to identify mass of oxygen? Mass of oxygen, very simple, because we have all the data in our hand. So we can go for that mass of that sample minus a mass of given mass of carbon, given mass of hydrogen, given mass of chlorine. So both we can add. So this is a sample. What is it sample? It is a first sample, no, that only. Okay, because second sample it is actually the oxygen is not bringing out. Okay, sample minus mass of carbon plus hydrogen plus chlorine, right? So sample how much? 29.72 milligram minus carbon how much? Carbon 11.25. Here I just put it that box, no, that one. Okay, so 11.25 plus 0.63 plus oxygen here chlorine 16.59. Yeah, 16.59. I just missed it. Okay, so everything it is in milligram only now. Okay, now you have to add and you have to subtract this. Right now you will get how much it is around. When you calculate this, you will get around mass of oxygen 1.25 milligram, right? 1.25 milligram of oxygen. Right, now you have to find out the empirical formula. So empirical formula, how you will find out given mass by molecular mass, and then simplest to whole number ratio, then finally you will go for that empirical mass. Okay, now empirical formula. So for that you have to go for number of moles given mass by molecular mass, no? So that is carbon, hydrogen, then next one what it is, chlorine and oxygen. So carbon how much it is, carbon given mass, no? So carbon it is 11.25 divided by 12, right? And this is hydrogen, what it is, 0.63 divided by 1, and chlorine how much, 16.59 divided by 35.5, right? 35.5, and oxygen how much, 1.25 divided by 16. Now what is it moles you can identify here? Now here you will get, what is the answer? You'll be getting 0.937, right? 937 you'll be getting, and here you will get 0.625, and here you will get 0.468, and finally you will be getting 0.078. Now simplest whole number ratio you have to identify, no, so that we can identify that what it is, empirical formula, right? Divided by, which is the simplest whole number ratio, 0.078. Here also 0.078 divided by 0.078. Of course this is, you will be getting one only, 0.078. So you'll be getting one only for oxygen, and chlorine you will be getting, when you calculate this, no, you will be getting around 6, and when you calculate this you will be getting 8, and this one carbon you will be getting around 12. So carbon, hydrogen, and what it is, chlorine, oxygen. So carbon, this is carbon, hydrogen, chlorine, oxygen. So carbon how much? It is carbon 12, and hydrogen 8, chlorine 6, and oxygen 0. That means only 1, not 0, right? So I just bring it in the box so that it will be easy for you to understand. So what is the Diel formula? It is empirical formula. It is actually C12, very big formula, C12H8Cl6O. So this is the Diel formula. It is an insecticide. I hope you got the clarity. Yes. Okay, now let us check the answer. C12H8Cl6O. It's very big, na? Okay. Drin as an insecticide we found. So C12H8 Cl6O. Yes, option C is the correct option. Yes, option C is the correct option. C12H8 Cl6O. See how much we have to bring that in that step for an empirical formula, and it is very important question also. Hope you got that some ideas from this explanation. Yes, come on, let's go to the next question. The next question, a gaseous compound is composed of 85.7% by mass carbon and 14.3% by mass hydrogen. Its density is 2.28 gram per liter at 300 Kelvin and 1.0 atmospheric pressure. Determine the molecular formula of the compound. See, this is like gaseous compound, no? So we can go in that way according to that. So density they have given. So ideal gas equation, we can go for it. So ideal gas equation, how do we go for it? They asked about that molecular mass, molecular formula, so that we can go in that way, rearranging for that molecular mass formula. Okay, so molecular mass of ideal gas equation, molecular mass of ideal gas equation. So here capital M we can bring it here, so that is equal to D into RT divided by P. Generally how we can bring it here, density equal to what is it? So density equal to what it is, PM by RT. That is what we used to follow that, right? So this is what we follow. So rearranging that, this is M, it is molecular mass. So we are bringing this side mass. So molecular mass equal to density into RT by T. Okay, density. So they have given the data, everything. Let us point out each data. Okay, density, how much? It is actually 2.28 gram per liter. Okay, mass by volume, no? So that is gram per liter. Gaseous constant, gas constant R, no? So this is 0.0821, that is actually liter atmospheric pressure, right? Now the next one, temperature also they have given. So temperature, what it is? So temperature it is actually, it is 300 Kelvin, right? Now next one, what it is? Pressure, what it is? 1 atmospheric pressure. So now can we apply that value over here? So molar mass equal to here density D, what it is? D RT by P, right? So D it is 2.28 gram per liter into gaseous constant 0.0821. What it is? It is liter atmospheric pressure, and T it is temperature, no? So into temperature 300 Kelvin divided by pressure 1, atmospheric pressure 1. So when you calculate this, you will be getting around what it is, molecular mass. Molecular mass only know this is 56.16 gram per mole, right? So molecular mass we found. Now we have to identify the empirical formula, then we can go for molecular formula, right? So empirical formula. So empirical formula. So empirical formula, we have to identify the number of moles of carbon and hydrogen, right? So number of moles of carbon and hydrogen, let us check here. So here gaseous compound composed of 85.7% by mass of carbon and 14.3% of hydrogen. So number of moles we have to identify. So for empirical mass, we have to find out that number of moles. So number of moles of carbon and hydrogen. So carbon, how much they have given number of moles here? 85.7, that is divided by atomic mass of carbon, it is 12, and the same way hydrogen 14.3%, that is a gram, given mass by molecular mass, no number of moles. So this is gram, and this is gram per mole, right? This is gram, and here hydrogen 1 gram per mole. So you will be getting number of moles. So here what it is, gram will be cancelled. So you'll be getting number of moles of carbon and hydrogen. So here you will get a 7.14 mole you'll be getting, and the same way here 14, yeah, the same number 14.3 mole you'll be getting. Right now hydrogen and oxygen, I mean hydrogen and carbon you found. Right now here simple whole number ratio. So this is a decimal, no? So you have to bring it in a simple whole number ratio. Simple whole number ratio. Right now here carbon and hydrogen. Carbon how much? 7.14, and hydrogen it is 14 point, 14 point, I just check it, 14.3, right? So here 7.1, so which is the simplest whole number ratio? Here 7.1 only, no, 7.1. So simplest whole number ratio, so 7.14. Here 7.14. So you will be getting 1 and you'll be getting 2. So here carbon and hydrogen. Carbon 1, hydrogen 2. So empirical formula, it is actually empirical formula, it is carbon and hydrogen CH2. So here CH2, it is a empirical formula. Empirical formula. So empirical formula, if you found means molecular formula, it will be easy, right? So what is the formula for a molecular formula? If you have to convert for that, it is very simple now. So empirical formula, you have to find out the mass. Empirical formula mass. Empirical formula mass. How much it is? CH2 no, so it is 14 gram per mole. Right. Now N equal to molecular mass by empirical mass. N equal to molecular mass by empirical formula mass. Right. So here molecular mass, how much it is? Just now we found no 56.16 divided by empirical formula. It is what it is. Just now we found what is 14. So you will be getting how much? When you calculate, you will get 4. So now finally you are reaching the molecular formula. So molecular formula, how to identify? Molecular formula equal to empirical formula into N. So empirical formula into N. So that means here empirical formula CH2 into number of N, how much? It is 4. So you just apply the value carbon and hydrogen. So here carbon 4, hydrogen 8. So this is the molecular formula. I hope you got the complete idea about it is going around the neck, but we are bringing the correct option from the gaseous statement. See, the questions are little higher level only, but it is very interesting and you can find such kind of questions only. Always you just try little more higher level so that it will be easy for you to improve your level of learning right now. So what is the formula? C4H8. So C4H8 is the correct option. I hope you got the clarity. Come on, let's go to the next question. The next question, a complete combustion of 0.86 gram of compound X gives 2.64 gram of carbon dioxide and 1.26 gram of water. The lowest molecular mass X can have. See, here complete combustion they have told, and then you are getting what it is, carbon dioxide and water. So 100% hydrocarbon only. So we can write that formula so that it will be easy for us to identify the answer. Right, CXHY plus oxygen, you will get what it is, CO2 plus H2O. So this is what, right? Now CO2, how much gram it has contributed? Right, this is 2.64 gram of carbon dioxide and water 1.26 gram of water, and here the compound, complete combustion of compound, right? So this is 0.86 gram. Right, now let us identify the number of moles of carbon and hydrogen so that we will come to know that what is that X compound molecular mass. Right, now here in that number of moles of carbon and number of moles of hydrogen we have to identify. So number of moles of carbon, here only one it is there, but number of moles of hydrogen, here 2 atoms are available. Okay, right, now here number of moles of carbon, that is actually how much? 2.64 divided by molecular mass, how much? Given mass by molecular mass. No, so this is given mass. Molecular mass, what it is? 44 gram per mole. Right, so this is also gram. Right, now here this and this will be cancelled. So what is the answer you will be getting? 0.06 mole you will be getting. Right, the same way, next to one, hydrogen. Hydrogen actually what it is? Twice. These 2 atoms are there, no? Twice. So number of moles of hydrogen. So number of moles of hydrogen. Here what it is? 1.26 gram divided by 18 gram per mole. 18 gram per mole, it is a water. So 18, it is a molecular mass of water. Into number of moles, how much? 2. Here because hydrogen 2 atoms are there, no? So that is the reason. Okay, now here the same way, gram cancel. So you will be getting around what it is? 0.14 mole. So hydrogen you are getting 0.14 and carbon you are getting 0.06 mole. Come on, let us identify the empirical formula. Now empirical formula, carbon and hydrogen. Let us check one by one. So carbon, how much? Carbon 0.06 and hydrogen how much? 0.14. Now which is the smallest number? So that means 0.06 only is the smallest number. Right, now here smallest whole number ratio. Okay, smallest whole number ratio. Right, okay, now here what it is? The same 0.06 and the same way here also 0.06. So you'll be getting around carbon how much? When you calculate, you will get 1 and you will get 2.33. So this is actually decimal, no? So we need a whole number ratio. So to make it whole number, whole number ratio. Right, now here carbon and hydrogen, no? So carbon, hydrogen, and here what it is? Carbon 1, hydrogen 2.3. So you just multiply with 3, right? Both the things. So you will be getting around what it is? Here 3, here 7. So you'll be getting here C3H7. So C3H7 you'll be getting. So what is the molecular mass of C3H7? Okay, so molecular mass of C3H7. So this is 3 into 12 plus 7 into 1. So you'll be getting around what it is? 43 gram per mole. 43 gram per mole. That is a molecular mass of CXHY of hydrocarbon, which is completely combustion from the gram of 0.86 gram. Right? They have given no. Right? This is what. Now, which is the correct option? 43. It's the correct option. I hope you got a complete idea. How do we go for it? See the question, how nicely they are bringing out. Actually, if we go through all these exercises, now really we will learn the main concept, and whichever question if they are giving also, values may be vary also, no problem, because we are thorough in that concept, and according to that we can deal this question, right? Come on, let us go to the next question. The next question, sulfate of a metal M contains 9.87% of metal. This sulfate is isomorphous with zinc sulfate, 7H2O. The atomic mass of M, actually we have to identify atomic mass of M, and it contains 9.87% of metal. Actually, okay, now come on, let us find out. So metal sulfate, it is actually M for metal, and the sulfate SO4, right? So metal, how much it is? 7H2O also. 7H2O. So let us find out the molecular mass of complete. So M plus sulfur, how much? 32 gram per mole, plus oxygen 16 into 4. That is 64 gram per mole. And water, it is 7 into 18. 7 into 18, that is 126 gram per mole. So total metal sulfate, it is actually, it is M plus, it is 101, it is 222 gram per mole. So you are getting this. Right now, let us find the mass percentage of M. So M contains how much mass percentage? 9.87 mass percentage. Okay, so mass percentage, let us identify. So mass percentage equal to mass of metal M divided by total mass. This is total mass. Right? This is total mass. Total mass, this only, right? Okay, into 100. Mass percentage, no? So 100. Okay, mass of metal, that is actually 9.87%. We can make it as a gram. Right now, here mass percentage, here what it is? 9.87% equal to, right? Equal to, this is M, mass of metal M divided by M, capital M, plus 222 gram per mole. Into 100. Okay, let us rearrange this point to calculate it very easily. So 100 M, this 100 into M, 100 M equal to 9.87 into 9.87 M, right? 9.87 M plus 222 gram per mole. Right? You got it? No? So this is of course into only. So now let us identify. So 100 M equal to 100 M equal to what it is here? 9.87 M plus 2191.4. Right? Now here you just bring M one side. So 100 minus 9.87 M. This is also M, right? I just bring that here 100 M, right? I just put 100 only. So 100 M minus 9.87 M. That is equal to what it is? 2191.4. Right now here what it is? So here what you will get here? M equal to, you just write M equal to, this is you are getting around 2191.4 divided by, how much you are getting here? 90.31. 90.31. Calculation, really it has taken, 90.13, sorry, 90.13. So you'll be getting around what it is? 24.31. So 24.31, it is the metal of that mass. So metal mass, it is 24. So 24 gram per mole. So this is metal only, no? So gram per mole. It is exactly magnesium. Atomic mass, it is 24, right? Now, what is that isomorphous of that, right? So this is MgSO4 7H2O. This is exactly isomorphous of zinc sulfide. See how nicely they are bringing the question. This is exactly isomorphous of zinc sulfate. This ATE, ITE really varies that number. Right now, which is the correct option? 24, right? 24.31, right? So 24.31, yeah, 24.3. Yeah, this is the correct option. Option C is the correct option. I hope you got the clarity how to deal this question. Come on, let us go to the next question. The next question. In an organic compound of molecular mass 108 gram per mole, carbon, hydrogen, nitrogen atoms are present in 9:1:3.5 by mass. Molecular formula can be. Right now here, we can find out the number of moles to identify this answer. Right now here, number of moles equal to number of moles of carbon, hydrogen and nitrogen atoms. Right now given mass by molecular mass, no? Yeah. So here given mass, it is actually 9, 1 and 3.5. What it is respectively. Right now, so this is carbon, right? So carbon, it is 9 and hydrogen, it is 1 and nitrogen, it is 3.5. And what it is, atomic mass we have to write right now. So here carbon 12 atomic mass, here hydrogen 1, here nitrogen 14, right? So now you will get that answer. What it is, the first one you will get around what it is 0.75 moles. Right now here one only, and here you will get around what it is 0.25, right? 0.25 moles. Right now here smallest whole number ratio, right? Smallest whole number ratio. So smallest whole number ratio, what it is, which is the smallest? This is only the smallest, right? Here 0.25 is the smallest whole number ratio. So carbon, hydrogen and nitrogen. So carbon, it is how much moles? 0.75 divided by 0.25. So here 1 by 0.25 and here what it is 0.25 divided by 0.25. So how much you will be getting answer? The first one, it is 3. Of course you will get 3 and here you will get 4 and here you will get what it is 1. So carbon 3, hydrogen 4 and nitrogen 1. So the empirical formula, it is actually what it is, C3H4N1. So here they are asking about the molecular formula. So molecular formula, for that what we have to do, that step empirical mass we have to identify for that. Okay, so we have to identify the empirical, this is empirical formula. So empirical formula C3H4N1. So the mass of empirical formula, it is 54. Empirical formula mass, it is 54. Now we have to identify the molecular formula. So what is the formula? We have to find out that molecular formula. So molecular formula equal to N into empirical formula, right? So N into empirical formula mass. So this is empirical formula mass 54. Right now here N equal to molecular mass by empirical formula mass. Okay, now here in that, so N equal to molecular mass by empirical formula mass. So molecular mass we know. So what is it? Molecular mass, it is 108 gram per mole. In the question it has mentioned, right? So it is 108 gram per mole. So molecular mass we know very well. So molecular mass, only molecular formula we have to identify. So this is 108 gram per mole. 108 gram per mole. And here what it is 54. There is no unit for empirical formula. Right now you will get N. What is it actually? You will get 2. Right now here N equal to 2. Now let us apply with this. Right now here what it is? So N equal to 2 into empirical formula. So empirical formula. So what is it empirical formula? So 2 into C3H. Here what it is? C3H4N, right? C3H4N1, right? So this is a bracket, actually it looks like C. Okay. So yeah. Right now you have to multiply with this. So C6H8N2. This is the molecular formula. Right? You got it? Molecular formula. Right? Each one, it is very, very important. I hope you got the clarity for molecular mass formula, how to use, and what is it N, and EFM, it is empirical formula mass, right? I hope you got the clarity. Now, which is the correct option? Actually, what is the answer? It is C6H8N2. C6H8N2. So option A is the correct option. C6H8N2. Right? Come on, let us go to the next question. That is what you two got it, right? Come on, let us check once again. Yes, got it. Right? So even if we get the answer correct also, while applying, if we put it in the wrong, then that will be the yeah. Come on, let us go to the next question. The next question, on analysis, a certain compound was found to contain 254 gram of iodine at atomic mass, it is 127, and 80 gram of oxygen, atomic mass 16. What is the formula of the compound? See, this is very simple. Here also formula, we have to identify molecular formula, right? So here This is very simple only. Come on, let us go and identify the number of moles, because they have given that mass and atomic mass also they have provided well and good. So easily we can identify that number of moles. Through that we can identify the formula. Right. Now here number of moles of iodine and oxygen. Right. Iodine and oxygen. Iodine, how much it is actually? Given mass by molecular mass, no? Given mass by atomic mass. Atomic mass. So what it is? 254, no? 254. 254, right? So 254 gram by atomic mass 127 gram per mole, right? And the same way here oxygen, how much? Oxygen, it is 80 gram by what it is? 16 atomic mass, 16 gram per mole. Right. Now what is the mole you will be finding? Here you will get 5 moles and here you will get around 2 moles. Right, so 2 moles and 5 moles. And actually this is whole number only. We used to go for empirical formula to identify, that is make it as a whole number, but both are what it is, whole number only. Iodine, it is 2 moles and oxygen, it is 5 moles. So no need to go further to change conversion in that whole, already it is whole number. So formula, what is that formula? Formula, it is I2O5, that's all. Right, very simple, right? So sometimes we can't even imagine like that. Very simple, they'll give I2O5 is the correct option. Option D is the correct option. I hope you got the clarity. Everything given mass, molecular mass, given mass, atomic mass, everything they have given in your hands, spoon feeding like. That's very easy. Only thing you should know the idea how to deal. Right? Come on, let's go to the next question. The next question, an element A is tetravalent and another element is B is divalent. So the formula of the compound formed these will be, right now element, it's very simple, easy only, but they are asking in a tricky way. Okay, element. So element A and element B. So element B. So element A, what it is? Tetravalent. Tetravalent. And this is divalent. So now how to write the formula? It is very simple. The formula it is A and here B. Usually crisscross only we will write now. Usually the valency method, how do we write that formula? Crisscross method. So A it is tetravalent and B it is divalent means. So here 2, here 4 means. So we will write here what it is. Here crisscross, no. So like this only, no. So here 2 and here 4. That is the way we'll write now, because here this is what it is, cation. This is positive charge, cation, and this is anion, negative charge, anion. So this is positive charge, tetravalent means plus 4, oxidation, right? And the same way here anion, it is minus 2. So here exactly you know what it is, tetravalent and divalent, it is CO2. It is only. I hope you got the clarity. So carbon dioxide only it is. So how do we write it? So here 2, here 4, easily we can simplify that. Okay, now this is AB2. Can we write it in this way? Right now, what is the formula? It is AB2. What is the original formula? So they have given in a explaining way. What is the original formula here? CO2. Right? I hope you got the clarity. That is what I've told. It is they are asking in a tricky way, but you are able to find out very easily. Right? Come on. Which is the correct option? Option AB2. Option C is the correct option. Come on. Let us go to the next question. The next question, a compound used in making nylon contains 43.8% oxygen. There are 4 oxygen atoms per molecule. What is the molecular mass of a compound? See, they are asking the molecular mass. And one more point here, 4 oxygen atoms are there in that nylon. You know the formula of nylon. Nylon, how do we get, that is adipic acid. Actually, adipic acid. So this is like indirect question. So adipic acid, what is the formula? It is C6H10. O4. So 4 oxygen atoms only available. So the molecular mass exactly when you calculate it, you will get what it is, 146 gram per mole. So if you know this trick, easily you can identify that. But still, they have given 43.8% of oxygen they mentioned. Come on, let us check how is it. This thing it is coming, right? Now percentage of oxygen directly you can go for in that way also to what it is to check that, right? Percentage mass of oxygen, like percentage of carbon, percentage of hydrogen, percentage of oxygen. You can go in that way also. But still, let us identify. So percentage of oxygen, in that way only we are going to go for it. So total mass of oxygen atom per molecule, right? Now one by one, let us go for it. Stepwise according to this sum, right? Total mass of oxygen atoms per molecule, right? So how much it is? 4 into 4 oxygen atom, no, 4 into 16 U, what it is, unit, oxygen atom unit, right? So you will get around what it is, 64 U, that is AMU. You can write U also. Right now, percentage of oxygen, second step, what it is, percentage of oxygen. That is what we are going to go for it, percentage of oxygen. directly. So mass of oxygen, right, divided by molar mass of compound, molecular mass of compound. Okay, molecular mass of compound. Percentage, right? So into 100. So molecular mass, we can bring it outside. So molecular mass of compound, right, equal to, so we'll go for it. So here what it is, so in that way here percentage 43.8 now, 8, that is equal to here 64, that is mass of oxygen, 64 divided by molecular mass into 100 when you are applying. So molecular mass of the compound we are bringing. Now how do we write it here? 64 into 100 divided by 43.8. Can we rearrange this? Yes, this is the way we rearrange. So 6,400 divided by 43.8. So when you calculate it, you will get what it is? Exactly 146.18 gram per mole. 18, it is least bother, so nothing to worry. So that is what I just mentioned. Adipic acid formula, molecular mass. So that it is used for that, what it is? Production of nylon. So that adipic acid is used to prepare that nylon 66, right? Nylon. What it is? 6,6 we can prepare through adipic acid. Adipic acid. You know what is the formula? Just now I just mentioned, no? Starting only. So what is that formula? Again, I would like to mention here so that you will remember that C6H10O4, 4 oxygen. First starting only, you would have got it. So when we go for that formula mass, it will be easy for us. So this is for checking to identify. Even this method you can utilize for checking method also, right? Now, which is the correct option? 146 as the correct option, right? Come on, let's go to the next question. The next question, suppose two elements X and Y combine to form two compounds XY2 and X2Y3. 0.05 mole of XY2 and 5 weighs 5 gram, while 3.011 into 10 to the power of 23 molecules of X2Y3 weighs 85 gram. Atomic masses of X and Y respectively. Right now here two compounds are there, that is XY2 and X2Y3. So these are the two compounds. In that data they have given what it is, 0.05 mole. This is actually 0.05 mole of XY2 and weighs how much it is, 5 grams. And this is X2Y3, it is 3.011 into 10 to the power of 23 molecules. And here gram, how much? It is 85 gram. Okay, now let us identify each. Right, now the first one, what it is, given mass of XY2, right? Given mass of XY2, number of moles we have to identify now, so that is actually 5 gram. So given mass and moles, how much? Moles, it is 0.05 moles. Right, now here molecular mass we have to identify for what? XY2. So molecular mass, molar mass, how to identify? Molar mass of XY2. I'm talking about this point. Right now here, given mass by moles, right, you will get molar mass. So given mass it is 5 gram and moles how much? 0.05. So you will get molar mass 100 gram per mole. Right, so molar mass of XY2, molar mass of XY2 equal to 100 gram per mole. Right, now the second one here, we have to identify this point. Now let us go here only so that it will be easy for us to understand. Right, now here molar, the second one you have to identify number of moles we have to identify now. So number of moles of X2Y3. So the second one, X2Y3, how do we go for? Number of molecules they have given now. So number of molecules divided by Avogadro number. So number of molecules, how much it is? 3.1 no? Yeah, it is 3.011 into 10 to the power of 23 divided by what it is? 6.023 into 10 to the power of 23. So you will get what it is, around 0.5 mole. Right, 0.5 moles you are getting. Right, now the second one, moles we found it. Now molecular mass we have to identify now. So number of moles we found it, and they have given what it is, weight, given mass they have given us. So given mass of X2Y3. X2Y3, how much it is? 85 gram they have given. So molecular mass equal to molecular mass of X2Y3. Right, so you will be getting what it is, 85 gram divided by 0.5 mole. So you'll be getting around what it is, 170 gram per mole. Right, now this is actually molecular mass of X2Y3. So molecular mass of X2Y3 equal to 170 gram per mole. Right. Now we can write the equation for that to identify the each one. Right now here, the first one, atomic mass X. Atomic mass X we can write it AX. And atomic mass Y, we can write it AY. So now here we can write the equation AX plus, this is first one, no, XY2. For this we are writing AX plus 2AY. I hope you got that idea. XY2. So X only one mole, that is AX, and 2Y moles, no, so that is what, 2AY. That is equal to how much molar mass we found out? That is first one, 100, no, that is first one, it is 100 gram per mole. I hope you got that idea. How do we go for to solve this? So 100 gram per mole, right? 100 gram per mole. No, I'll change the color, same color. Gram per mole. Right now, the second equation, what it is? 170 gram. That is X2. I'll change now. The color will be variation. X2 Y3. So for that, A, that is 2AX, right? Yes, 2AX plus 3AY. I hope you got the clarity. This is 170 gram per mole. So this is equation 1 and this is equation 2. Now here, equation 1 and equation 2, we can bring that idea, what it is, equation 1 and equation 2, that equation 1 we can multiply with 2. So this equation 1 we can multiply with 2. So this equation we can multiply with 2. Why? To what it is, balance that equation. So when you multiply with the 2, so you will get what it is, 2AX plus 4AY. I hope you got that idea. So you're multiplying complete equation equal to here 200 gram per mole. So this is equation 3. Now this and this will be cancelled now. Okay, now here you will get what it is. You will get here 1, right? 1AY. Right here 1AY equal to how much you'll be getting? 170 minus 200 actually when you go put upwards, no? So you will get 30. So 30 gram per mole. So Y equal to 30. So AY equal to 30 gram per mole. So we can substitute this value into what it is, AX. So AX plus 2AY. So AY equal to 100 now. So that means we can apply the value over here. So we can substitute. This is equation 1 now. This is gram per mole. 2AY. This is AX plus 2AY. This is equation 1 now. So let us apply the value, AY value we can apply over here. So AX plus 2 into 30 equal to 100 gram per mole. I hope you are clearing all these points right now here. That means AX plus 60 equal to 100 gram per mole. So that means AX equal to what it is? AX equal to 100 minus 60. 100 minus 60 you will get 40. So AX equal to 40. Everywhere gram per mole, right? Because molecular mass. So AX equal to 40 gram per mole. I hope you got that idea. AY equal to what you got it? 30 and AX equal to 40. Right now AX equal to 40 gram per mole and AY equal to 30 gram per mole. Right, gram per mole or unit, anything, AMU, anything you can write it. I hope so. You are getting 40, 30. So the complete idea, I hope you got the clarity. This is very interesting question, very lengthy question, but really it is very interesting nowadays. In the board level also, they are asking such kind of questions only. For competitive level also, all the competitive level you can expect like these questions. Not only for that JE mains, even all the competitive level, logical way thinking, nowadays they are asking such kind of way. Now teaching method and learning method also, books also, it is everything, it is changing. So you have to improve your logical way of thinking. Presence of mind, you have to be very active. Right now 40, 30, no? 40, 30. So 40 AX, X is 40. Yeah. So X is 40 and yeah, X is 40, Y is 30. Okay. So which is the correct option? Option C is the correct option. Come on, let us go to the next question in our next video. Hope you understand all these things, all the questions. And thank you for watching.